Hi, my name is Kumar Rajiv. I'm from Windows Driver Framework team, and today I'm going to talk about advances in driver development. Here's the agenda for today's talk. We'll first go through an overview of advances in driver development. Then we'll talk about UMDF 2.0, which is a new feature in Windows 8.1. Then we'll go through a demo of reusing code to move between UMDF and KMDF. After that, we will talk about summary of new WDF features, followed by key takeaways. So here, let's start with an overview. Nobody likes system crashes. They result in bad user experience. And we know that buggy drivers are biggest contributors to system crashes. So before deciding to write a driver for a new piece of hardware or a peripheral, it is important to ask the question, do we really need to write a driver? Are there other alternatives available? Well, Windows 8.1 enables new scenarios by providing new Windows runtime APIs for industry standards like Bluetooth, Bluetooth Smart, HID, USB, and Wi-Fi Direct, where you don't really need to write a driver. We call these protocol level access as apps communicate using a private or published protocols over industry standard transports and protocols. And these are all done over Microsoft Inbox drivers. Imagine prototyping a peripheral with an app written in JavaScript with HTML without needing to write a custom driver. There are various talks on scenarios and protocol APIs that you may want to explore in this conference. If you really need to write a driver, you should start to write a WDF driver. Briefly, for those of you who are new to driver development, WDF is a driver model that simplifies driver writing by abstracting complexities of PNP and power handling, I/O queuing, and communication with the rest of the system and other device stacks. It consists of a user mode driver framework, in short UMDF, and a kernel mode driver framework, or KMDF. In the past, even though KMDF and UMDF followed an overall similar driver model, UMDF exposed COM programming interfaces, whereas KMDF exposed flat C interfaces. Also, they both had separate reference documentation and debugger extensions. Driver developers had to choose between KMDF and UMDF before the beginning of the project. Even though UMDF gained feature parity in several areas over time, such as in hardware access and interrupt handling, there was a concern of getting stuck later in the project due to lack of certain features, ending up rewriting from scratch with KMDF. In Windows 8.1, we are introducing a new version of UMDF called UMDF 2.0 that is unified with KMDF model and allows easy reuse of code, so you don't have to worry about getting stuck at any point with UMDF. So when you're writing a new driver, you should always start with UMDF 2.0. We'll talk more about UMDF 2.0 in more detail in this talk. Here's just a recap of why we should use user mode drivers. User mode drivers run in user mode process, so if the driver crashes, it doesn't take down the whole system. Instead, just the process hosting the driver crashes. It also means they pose much lower risk to the system than a kernel mode driver. In addition, user mode environment is much simpler to deal with during driver development. You don't have to reboot the system every time the driver crashes. Development and debugging can be done on the same machine instead of two machines required for kernel mode driver development. Now let's talk about UMDF 2.0. UMDF 2.0 is the new version of UMDF. UMDF 2.0 has been unified with KMDF model. So there is just one unified WDF model. There is one common WDF DDI set instead of separate KMDF and UMDF. And more importantly, there is no more COM-based programming interfaces. So you can reuse same code for KMDF or port KMDF to UMDF 2.0. And there is very little effort required to switch from kernel mode to user mode and vice versa. Here I'll show you a comparison between UMDF 2.0 sample code and KMDF sample code. On the left is a sample code from UMDF 2.0 driver. On the right is sample code from KMDF driver. If you look closely, you'll find there is absolutely or almost no difference between the two. There is a minor difference with respect to use of WPP macros, but otherwise all of the WDF callbacks and APIs are all exactly same in both UMDF and KMDF. For example, UMDF driver has driver entry as its entry point, just as KMDF driver. UMDF driver on the left is using WDF driver create to create a driver object, just as KMDF driver on the right. So you can see how simple it is to move from UMDF to KMDF because of common DDI set and common model. Now, there is a lot of feature parity that we gained with this release as well compared to legacy UMDF. For example, in this table, you could see in many areas, both KMDF and UMDF support the features. For example, WDF object, WDF device, WDF driver, IO queues, targets, and utility objects such as wait log and work item, and WDF key. However, there are still certain areas where UMDF does not support certain features. For example, if your hardware uses DMA or your driver is a bus driver, then you still have to write a KMDF driver. On the other hand, UMDF does provide you certain features which are not available in KMDF. For example, a fatal error in a UMDF driver does not crash the system, whereas in KMDF, it will crash the system. Also, in a UMDF driver, if the driver crashes, system will restart the driver without rebooting or without crashing, whereas in a KMDF driver, a fatal error is just system crash. So we have one unified WDF DDI set, as I mentioned earlier. There are more than 200 DDIs in common with KMDF and UMDF. And most of the non-common ones are because of unsupported UMDF features. For example, DMA feature is only supported in KMDF. So there are no DDIs for DMA available in UMDF. So because of a lot of support for common set of DDIs, we were able to move many inbox drivers, many Microsoft-owned drivers to UMDF 2.0 during 8.1. For example, NFC and point-of-sale stacks and some more. Because we unified the KMDF and UMDF model, we were able to provide a unified WDF DDI documentation as well. So there is one reference and one design doc for both KMDF and UMDF. Those of you who are familiar with WDF programming, they might remember that there were two documentations separate for KMDF and UMDF, and every time you moved from UMDF to KMDF or vice versa, you had to go and explore the other documentation. Now here, for example, we have documentation for WDF interrupt create, and that applies to both KMDF and UMDF. So you don't have to worry about going around and finding out the documentation for other model that you might end up porting to. We also have one unified WDF debugger extension now. So the same debugger extension that worked for KMDF earlier now works for UMDF as well. For example, here I have shown Bang WDF LDR output. Those of you who have used KMDF debugger extension know that Bang WDF LDR gives a list of all the KMDF drivers loaded. As you can see here now, the output also shows a list of UMDF drivers loaded. There are also new debugger commands that we added to the extension. We now have improved debugger extension as well. For example, output of several commands provide links that you can click to invoke other commands. So it's easier to debug. As you can see here in the snip, the commands have links, and clicking on those links execute certain commands. This is especially useful for UMDF. Those of you who have done UMDF debugging in the past know that it's not straightforward to debug a UMDF driver. First of all, many instances of the driver may exist in different user mode processes. And in that case, you first have to find out the right process for your device instance that you are going to debug, and then switch into the context of that process. Now, with these new debugger extensions, we have this DML link on commands. When you click on them, it will automatically switch into the right process context, and then you can execute more commands once you are in the process context. We have also improved debugging support. UMDF 2.0 provides an always-on, always-available UMDF log, just as the KMDF log. Now, this log is available even after the user mode driver has unloaded. Those of you who have debugged UMDF driver, they know that many times the UMDF driver may unload while the process is still there, and then it becomes very difficult to find out what really happened with the driver. With the UMDF 2.0 log, you'll be able to get more information about the unloaded driver as well. We have added new samples and templates to Visual Studio. We have a toaster function driver and a filter driver sample, a sample for echo driver, a sample for USB FX2 device, and a sample for single component power management driver. We have also added some new Visual Studio project templates for UMDF 2.0. There is one for minimal driver project. There is one for empty driver project, which has no source code, but it does generate INF and other project settings so that you can copy code from other driver, and for example, you could copy code from KMDF driver into this empty driver project and then be able to build a UMDF driver quickly. We also have a project for USB driver. Here is a recap of major benefits of UMDF 2.0. If you already know KMDF, then it's very easy to switch to UMDF because it's the same model. There is also an escape path if UMDF doesn't work out for you. So if you started using a UMDF driver project and you are in the midst of the project and found out that certain features are not available, then you can always reuse the same code and compile for KMDF. And we'll show that in a demo as part of this talk. You can also port your KMDF driver back to UMDF 2.0 as long as the driver uses supported features. And one last thing, that you don't need to learn COM anymore. Now let's get to the demo showing code reuse. In this demo, I'll show you how to easily reuse code to switch from UMDF 2.0 to KMDF and vice versa. So we will first build a UMDF 2.0 driver from scratch using the Visual Studio template. Then we will install the UMDF 2.0 driver in a virtual machine. We will then use the new unified debugger extension to dump the driver information about the UMDF driver in kernel debugger. We'll create an empty KMDF driver project from Visual Studio template. This project doesn't contain any source code. We'll then copy the UMDF 2.0 driver source code to this new empty KMDF project, and then make minor updates to the source code and build the KMDF driver. We'll then install the new KMDF driver alongside the UMDF driver that we just installed. We will then view the two drivers in the debugger. So let's start with creating a Visual Studio project. Here is the Visual Studio, and I will create a new UMDF project. As you can see here, there are a couple of more options than what was earlier available. For example, we added templates for UMDF 2.0 here. So let's select UMDF 2.0 project from here. Let's name this as, let's add the suffix demo. And let's create the project. It will take a few seconds to create the project, and the project will be completely deployable, and you wouldn't need any more components to be able to install the driver or debug the driver. Now let's update the properties so that the driver is deployable. Let's also choose the target computer, which is the virtual machine that I have already set up for this demo. And let's apply the settings. You can look at the source code here. You can see driver entry here. Now let's build this project. And as part of building the project, it will also be deployed. So let's go to the virtual machine. And here you'll see the driver being deployed. It will take a few seconds to completely install the driver. And the driver should appear in the device manager. And here you can see the driver. It is the one that we created. As you can see, the suffix has demo in the name. Now let's go to the debugger and try to get some information about the driver using the latest debugger extension commands. Let's break into the virtual machine and use the same debugger command that was used earlier for KMDF for listing the KMDF drivers, and that is bang wdf ldr. As you can see here, apart from getting a list of KMDF drivers, you are also getting a list of UMDF drivers. The one that we installed is the only UMDF driver present in the system right now. So let's click on this link on the name of the driver, and you can see here we get information about other commands that we could execute. For example, you can get the log dump from here. You can switch into the process context by clicking on this link, and also you can get driver info by clicking on this link. And clicking on this link will also switch into the right process context for you. For example, here the command, when you clicked on it, actually executed a command to first switch into the process context, and then it executed the command bang wdf driver info. Here again you have output that contains DML or debugger markup language links. If I click on bang WDF log dump, it will give me a list of logs for various processes. In this case, we just have one instance, and that is located in this current process. So let's click on this, and we get the log. So now we have seen how easy it is to debug a driver, a UMDF 2.0 driver. Let's now go to Visual Studio and see how easy it is to port a UMDF driver to KMDF and vice versa. Now I will create a KMDF project, an empty KMDF project that doesn't have any source code. Here is the empty project, and I will name this. I'll add a suffix of demo here as well so that you can distinguish between other drivers from other drivers. I'll change the property so that it's deployable. I'll update the target computer name to point to the virtual machine, just as we did for UMDF 2.0 driver. Then we'll apply the settings. Now we build the driver. At this point, if we build the driver, well, there is no source code. So let's first copy the source code from UMDF 2.0 project that we just created. So this is the one that we created. We copy all the .c and .h files. To the KMDF project that we just created. We load these files in the project. We load all the headers in the project. And now we build the driver. At this point, if we build the driver, we'll get some errors because we still need to make some minor modifications. So let's first get to the code that we need to modify. One thing that you need to modify is that you want to make sure that the KMDF project points to ntddk.h instead of windows.h. Windows.h is used by UMDF drivers or user mode components, whereas ntddk.h is used by kernel mode drivers or KMDF. So let's make this change to point to ntddk.h. Also, we need to make sure that WPP macros are taking correct number of parameters, because WPP init and WPP cleanup macros have different set of parameters for kernel mode components and user mode components. So we'll go in the driver.c and look for WPP macros. Here is one, and we will provide the correct set of parameters for kernel mode component, which is driver object and registry path. Here is another WPP cleanup macro. This takes driver object as the parameter, so we will provide that. there is one more line of WPP cleanup. We'll just copy this one and then paste it here. Those are all the changes that we need to make. So let's now compile this. It compiled fine and it's now deploying. Let's go to the virtual machine. And here you can see it's being deployed right now. It's still being deployed, but you can see in the device manager, the KMDF driver is already there alongside the UMDF driver that we just created. So you can see how easy it was with a couple of changes. The changes look pretty straightforward. So it's pretty straightforward to move from UMDF 2.0 to KMDF. And you can use the same steps to get back from KMDF or port from KMDF to UMDF 2.0 driver. One last thing we'll do here is just look at the debugger extension, dump the driver info for KMDF. We'll use the same command, bang WDF LDR. And the first entry in this case is the KMDF driver that we just created. Let's click on this. And you can see the output is pretty similar to the UMDF output. There's a bang WDF log dump link. Click on this, and you get the log, just as in UMDF. So you can see how similar, in fact, how exactly same they are in terms of debugging capability and in terms of the code for WDF. So let's now get back to the remainder of the talk. Now let's talk about some of the new WDF features. Here is a list of new UMDF 2.0 features, and we have gone through this already, but I'll just quickly go through them. We have one unified WDF model, where UMDF model has been unified with KMDF model. There is no change in the KMDF model. It is the UMDF model that has been unified with existing KMDF model. We have flat C APIs for UMDF. We have more feature parity with KMDF. We have always on, always available WDF trace log support in UMDF. We also have component level or F state power management support, limited to single component, single state management. We also have WDF class extension support. We added new samples and templates, and we enhanced the debugger extension. We also added new features to KMDF. KMDF now supports high resolution timer. It also supports device wake through wake capable interrupts. We added new DDIs for accessing unified property model properties. And as you saw, we made enhancements to the debugger by adding DML links to several commands. Now let's get to the key takeaways. Consider whether you really need to write a driver. See whether you can use new scenario APIs or protocol access APIs and avoid writing a custom driver. And there are talks around scenario access and device access APIs in the conference that you may want to listen to. When writing new drivers, you should always start with the new UMDF 2.0 model. Since UMDF 2.0 model is now more unified, you don't have the concern of getting stuck at a later point in the project with UMDF, because you can always reuse the same code and get back quickly on a KMDF driver. Here are some related sessions that you may want to listen to. These are some of the sessions that talk more about how to develop an app and establish communication with your peripheral or hardware without writing a custom driver. Thank you very much for your time listening to this talk.